This for allowing me to present this particular topic. I'm not a researcher, as she mentioned. I'm not a researcher or or a scientist in astronomy, astrophysics, but I have taught the subject at undergraduate and postgraduate levels, and many of our students are contributing to this particular field, especially women students. So I would like to briefly introduce what we have done in our department to contribute to astronomy and astrophysics. So the title is Women in Astronomy and Astrophysics from School, College to Being a Professional Astronomer. Okay, so interest in astronomy at school level. First, I'll start with this because our students go to schools as a part of public outreach and teach science, physics, and astronomy to schools children here. So general observations indicate that significantly majority of our school students in India have a very keen interest in astronomy in spite of limited resources and exposure in many parts of the country. Now, some 15 years ago, from that onwards, the success of ISRO and media coverage in missions like Chandrayaan, Mars orbital mission, AstroSat, these have ignited immense public interest and inspired the youth to pursue careers in astronomy, astrophysics. Earlier, this was not the case. So because of the media coverage of the ISRO missions, many people in school got excited because of this. As far as the gender difference are concerned, very little difference is observed and not very pronounced at the school level, suggesting a relatively even distribution of interest, but access and proficiency varies by socio-economic background. When I say socio-economic background, I'm talking about schools which are low-income schools and the private schools. So there, the little difference is there. Otherwise, we didn't see any difference. Sorry. Yeah. So this is observed in low-income ZP schools. So our students have also gone to the Zilla Parishad schools. These are the municipal corporation schools, very, very low-income school where students from a very low-income background come. So both the genders showed a keen interest in astronomy, especially when the mentors were our own girl students. This is very interesting because when the boy students are teaching, the students have a different, the girl students have a different response. And when the girls themselves are teaching this subject, the girl students have a very, very different response because they see that we can also be something like them, or we can dream to be an astronomer in future. So these are the top two slides are from the low income school students, and the bottom one is from a private school. So this was also compared in the private school, that in both the cases, at school level, both boys and girls are 50-50 interested in astronomy and astrophysics. Now we come to the college level where I teach undergraduate students and postgraduate students. So after teaching astronomy and astrophysics in college for both UG/PG classes and involved with the astronomy club. So this helps students to to gain more interest in astronomy and astrophysics, because I've noticed these clubs, club activities everywhere do help students to gain some different knowledge. So for the past 28 years, it is noticed that the ratio of girls to boys with inclination towards astronomy subject is similar. So again, I'm talking about undergraduate level. If you have club activities, I have never seen very less girls. I mean, Priyanka she has experienced this in our college, that both boys and girls take part in activities and are interested in astronomy, astrophysics. This is due to similar exposure to both the genders at an early age, depending on the background of the college or the school. So it's 50-50 till here. Sustained interesting factors. Now here, astronomy club activities play a crucial role in sustaining the interest in the subject. So for both genders, sustained interest in astronomy careers through high school and UG college years is significantly linked to extracurricular activities. In India, unfortunately, in many places, this is not the case. If we have colleges, universities with extracurricular activities related to astronomy, astrophysics, yes. Examples are stargazing sessions, astrophotography, seminars, workshops, and small projects. I'll give you some of the examples in our own department. Group discussions. So here weekly discussions are there on various topics in astronomy, astrophysics. So students gather around in the evenings after college hours. They have brainstorming sessions on some astronomical topic is given. Everybody contributes. Here again, undergraduate students, the levels are different. So you have first year, second year, third year. So everybody contributing, the seniors helping the juniors and so on. So this is one of the trends, group discussions. Next, we have poster exhibitions also yearly. Here again, a topic is taken, students study the topic, they make their own posters, the public is invited, that means other schools and colleges also come to the college, they explain. This is a 2 to 3 day event. So here again, the interest in astronomy is ignited. Next, the National Science Day, 28th February. In Pune, we are lucky to have Ayuka, NCRA, GMRT. So especially to GMRT, our students go and take part there as volunteers. In Ayuka also, the entire nearly, whoever is from Ayuka here, most of the Ferguson students come and take a role in volunteering where thousands of people come there on Science Day. Then again in the college, we have workshops and lectures. Ma'am has also, I think, attended one of the Frontiers in Physics seminar. So lots of workshops, lots of lectures on astronomy, astrophysics, again ignites their interest in astronomy and astrophysics. So now here I would like to present the data of our own students. I have a data here of 105 students of mine. You can see that from this particular table, if we say 105 students data, of course, Priyanka is also included, one of the persons in the data. So we have male students 65, female students 40 total. The people who have done doctorates in, that is PhD in astronomy and astrophysics are 40. Out of which 18 are girls, 22 are boys. So again, I would say a 50-50 ratio. That is not the case with MS. MS, I'm not talking about a normal MSc or an MSc, I'm talking about special astronomy astrophysics MS. MS in astronomy and astrophysics, male 43, female 22 students. Again, graphically, if you look at this, you will see that MS in astronomy and astrophysics, male students are more, females are less. I'll give you some reasons might be there, which we will discuss. As far as doctorates are concerned, again, 50-50 ratio. So there is a change here. So why is this happening? So interest in astronomy at PG level, this ratio, however, does not remain the same after UG. For master's courses in astronomy and astrophysics, are very, very few institutions have masters in astronomy and astrophysics. Then this particular subject, I mean, girls prefer taking physics for masters rather than astronomy and astrophysics. The reason is that they want to do astronomy astrophysics, but the institutions which have special astronomy and astrophysics is not in the geographical area where they might be staying, and they are maybe not allowed to go away. I have had a talk with some of the students when they want to do this. They say, no. I mean, the family wouldn't want to let them go somewhere far away. They say, you do some of your masters around here. So they prefer taking physics, and then later on they might take for PhD, astronomy, astrophysics. So for MS, you will see that the ratio is very, very less. Males have 65, 66 of them doing masters in astronomy, astrophysics. Female ratio is much, much less. I'm sorry again. Yeah. So after completion of master's course, it is found that many women pursue their PhD in astrophysics. That means physics wale also, and special MS in astronomy, astrophysics wale also. This is again because scholarships are also available for PhD. So they can go to any institution, physics plus astronomy MS people. So here the ratio is more. Other things which one of the speakers has also mentioned, further, there are other hurdles for women in astronomy, like if you talk about historically, women have always been denied university education and higher official posts. This was a trend, and I think little bit it's not changed much. There is lack of recognition and underestimation. Contribution of women has always been neglected. We have a very good example, Jocelyn Bell. Although the percentage of women with doctorates in astrophysics has increased, there is still a significant drop-off at senior levels. Like leaky pipeline, what she just mentioned. There is still a significant drop-off at senior levels, with women remaining underrepresented in higher faculty positions and leadership roles. There are also other issues like workplace culture, gender bias and discrimination. Of course, nobody talks much about it. We just hush it up and continue working. Work-life balance and family responsibility, just now again it was mentioned. Break in career, many women have to take a break in career, especially after marriage and maternity leave and so on. That is another reason. Then we have this two-body problem. When you're married, you have a spouse. Women often limit their career options. They relocate for their partner's job or maintain a separate residence from family, making it difficult to both of them to find academic jobs in the same city. The husband and wife, the wife may be an astrophysicist, but she's always with the husband. And in that particular city, you may not have an institution where she can contribute. She wants to, but so there's always a problem here. So finally, I would like to say sincere efforts are being made by the International Astronomical Union, Women in Astronomy Working Group, and others to increase awareness, gather data, push for structural and policy changes to address these existing issues. And the ICTS Waves is one of them. Thank you. So thank you for inviting me here.
Very nice talk. So I would like to open the floor to questions. So there is a question there.
By the way, in this particular conference also, we have 1, 2, 3, 4 of us from the same department. One, I think, has joined online. So all these women are from the same department. So I'm really happy about that.
Thank you for this nice talk. A question and a comment. Okay, first thing is like you were telling you were situated in Pune and you have Ayuka, everything nearby. So how important it is to have such institution coming down to these colleges and schools, you know, the help you get from them that do have an impact on your activity there.
Are you asking, are you telling about the institution's help or the college itself going?
Like you get help from institutions to do that.
No. As far as outreach activities are concerned, we don't get any help.
Okay.
But we, right now, for example, after this 28 years of all the work we have done, Ayuka has given me the coordinatorship of an ICARD center, Ayuka Center for Astronomy Research and Development. So yes, now they will be giving us some funds. Sometimes earlier also they used to give us funds to carry out workshops and so on.
Okay.
But this outreach, we are doing it on our own for the public as far as the school outreach.
So I'm asking, like, wouldn't it be very helpful if institutions somehow come into colleges and
yes, Ayuka in that way, there are 40 ICARD centers in India. So they are expected to carry out these activities. But as far as my knowledge goes, most of these activities are for the PG students, workshops, and so on, not at the school level. But yes, for school level, you don't need an institution to help you. Any college with any undergraduate student, postgraduate students can always visit schools and popularize physics, astronomy, and so on. So you don't need an institution for that. And believe me, these schools are also so happy, the teachers there and the headmasters there, that you have taught. They are unaware of what astronomy is all about. So even if you give a simple talk on any topic in astronomy, but the school teachers are also very happy, and they always feel that we never heard of these kind of things because they have not been exposed to this. So any student can do this, visit a school. They also thank us and give letters of appreciation that thank you for coming and giving this kind of different kind of a talk, because still this subject is not there at school level. So that does help, yes.
Yeah. And one more thing, like I would like to invite all of you to my poster wherein I talk about women in leadership in STEM. So I'm just putting forward some ideas like that. Thank you.
Okay, Preeti.
So Raka, it was very nice to see those numbers that you presented about.
Just to add to that, that 105 number, I think I'll just go back to that number. No, sorry. Also, this is the list of the students of ours, that 105 number, all of them doctorates and all, all of them doing their masters and also, and this figure is always changing every year. So actually, after 105, two more were added later on. I didn't add them in this thing. So this is the actual. Anyway, so all these people are actually. Those who have, half of them have done their PhDs in astronomy, astrophysics, and are contributing somewhere. I mean, like her again, because she is present here. And people who are doing MS, and some of them are doing PhD, so they will be passing out. So that's the number. I mean, particularly in astronomy, 105,
Okay.
107 now.
Yeah, so what I was asking was, I mean, is this, I mean, so first of all, it's excellent that you have this data. We need these data for colleges and universities, and we usually never, end up getting those. So are you planning to, for example, make this public somewhere? I mean, that would be a suggestion if you could make it public.
Believe it or not, in January, there is a conference in Ayuka on public outreach.
Yes.
So we were planning, the college students and me were planning to, send whatever we have done at
Yes.
public outreach. So
Okay.
because vacations were going on, we didn't do it before the deadline. But even before the deadline, who is this? Divya Oberoi called me up. He said, "Ma'am, you have done so much activities. Why don't your students?" I said, "We are going to, but because of vacations, sometime it'll take." So they have extended the deadline, and all this thing, yes, will be presented
Yeah.
there. So we have presented this at ASI also. Many of the students have done
Okay.
their poster presentations at ASI and also in Ayuka
right.
recently. And I don't know whether I should mention this, but the INSA, Indian National Science Academy, had awarded me with the teachers, INSA Teachers Award for all these things.
Activities.
Thank you.
So that is fantastic. Yeah. You should. So, because I wanted to encourage you and other people who follow to kind of keep these numbers, and
Yes.
yeah, we need
Yes.
this for,
Yes, yes.
carrying
Because
out
all
statistics.
these people are in contact with me.
Very nice. Okay, thank you.
I have a follow-up question on that.
Oh.
I just find the number a bit small in the sense that for 28 years,
The activities have been going on for 28 years, yes. But when we talk about, see, as I said, the astronomy as a science or as a career, that came only after ISRO's media coverage. Before that, nobody really knew. I mean, all of you who are of my age or something, you just got into it. Maybe there was no public awareness about this. What you are saying, yeah, I'll come back to you. She's mentioned about so many years doing 105 is no big deal. Maybe I'll give you an
not
example.
no big deal.
No.
I feel like
There should have been more. Okay.
More, or is it because the number of seats were less to begin with? Or
No, there are other issues also. Some of the students like leaky this thing. What happens, believe me, because many people know that astronomy, astrophysics exists in our department, so people want to take admission there, those who are interested. Okay, fine. Some people come to me, parents, "Oh, this is my daughter, she's interested in astronomy, astrophysics, will you guide her?" Okay, fine. So you talk to her for 5 to 10 minutes, aisa karna hai, waisa karna hai, and at the end of that 10-15 minutes, the question I get is, "Okay, ma'am, if I do my master's or BSc in astronomy, astrophysics and master's in astronomy, astrophysics, what package will I get?" Oh my God, I can't answer that question. I have been asked that question. What will I get? Whereas in other industries, they talk about package. So I was suddenly taken back. This is what happens, that everybody. It's so difficult when you are doing MS and then 5 to 6 years of PhD and then another 2-3 years of postdocs. At the end of it, where do you stand? That is not the case with other areas. So some of them feel that most of these students, other students who have done masters in physics and all, later on they didn't come to astronomy because they found joining some company or doing some software jobs is much better. So though initially they were interested in astronomy, astrophysics, they were doing it, but then they leaked off to other areas rather than stuck to astronomy, astrophysics. So this is another problem, because many times we talk about outreach and astronomy and this, but if you say at the end of my PhD, what do I do? After postdoc, what do I do? There are no jobs in India as such. Everybody knows that. This is very difficult to answer this question. What do I do after that? But for engineering people and all, you know that in a year or two, they are placed somewhere, they're doing fine. After all, it comes back to that.
Thanks.
Questions? Yeah, there is a question there. Madhava, mic.
In just a small comment about what you were saying now. So even in engineering backgrounds, the next already there is a kind of stagnation that has come up because of AI and stuff. So during COVID, people were getting like 100% hikes and everything. And now a lot of people in big MNCs are on benches, as in they are not getting projects to work on. So even in engineering, things are becoming uncertain. And yeah, as long as we can know our job well, as in what we do, we can get opportunities.
Yeah, but as I said, even in engineering, the same thing. But again, students from engineering also are going into data science and all these places. So the same question. But in astronomy and astrophysics, there's a big difference here compared to engineering students. At least they can join some place, some company, some industry. That is not the case with a person who has done a PhD in astronomy, astrophysics, and a postdoc. It's more difficult for them.
Okay, one more question. So in the beginning, you had mentioned that women students or girl students teaching it creates a huge difference, as in how it is perceived by the
I
young.
just tell you, a small school children's mind, you know, if you're showing a picture of a doctor, a male doctor, okay, a picture of an astronaut, a male astronaut, a picture of a scientist, a male scientist, then subconsciously they feel these are male-oriented careers. But if a female is also shown, and if a female is teaching them astronomy, astrophysics, they have this feeling, I can also become one of them. So that little difference it does make. So even whatever workshops we do and the conferences and seminars we arrange, we do make sure that the male and female speakers are invited. So even our college students should feel that, yes, there are speakers, female speakers in this particular area.
I see, I understand.
Something.
You can have the mic, just a minute.
Yeah, thanks. Very nice talk and insightful. So I just wanted to second your thoughts about the lack of exposure in the schools, like specifically if you're talking about state government schools. And
yes.
So going to these schools, I have been also doing it in my state when I was like, so it really helps, and you really find only handful of students. And even if by motivating those handful of students to be in science, it really gives you a different feel and energy of what we are supposed to do in this field. And apart from that, I also would second the other thought which you expressed, or rather the cause of lack of students joining sciences. So I was also surprised to hear from one of my friends, and she's like a close friend and also colleague. We did our PhDs and postdocs all together. And then she joined a college somewhere in Mumbai. And I was surprised to hear that one of the colleagues actually is giving that sort of thought, or expressing that thought, that she's not getting a permanent position anywhere. And that has been expressed in front of students, like she has done a postdoc from, say, blah, 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 big institute, and then not getting a permanent. That gives a false, or I mean, it's not false, but it gives a wrong impression about how science,
But again, coming back to school, just now the Maharashtra government has introduced that in all schools there has to be some extracurricular club activities. And believe me, people, there are many schools who are going to start astronomy club because they find that something you can say catchy or something. But later on, what happens? We have I don't know how to explain to people what careers. I mean, what can you do after a postdoc in astronomy? Everybody here is facing that problem, and I'm sure that remains a problem.
I have a couple of points. First is that Maharashtra is particularly good in astronomy, astrophysics, thanks to Professor Narlikar.
Yes.
The popularity and through these Khagol Mandal efforts. So what you are seeing is also a very rosy picture compared to the rest of the country.
Yes, that's
right?
very true.
With so many students getting exposure to astronomy and astrophysics. That's the first point.
True.
And secondly, I don't consider the issue of like finding a job in astronomy, astrophysics as isolated from somebody doing any other kind of basic sciences. Other than say right now the boom is with chemistry, synthetic chemistry, biology. Physicists are also facing the same problem. And I'm actually not too averse to people not find, because we clearly don't have enough job in academia. So even if you have a lot of trained manpower, you are not personnel, sorry, the word, trained personnel, they will not, all of them cannot be accommodated in academia, but that's not such a bad thing because astronomy per se actually trains people in a lot of skill sets which are valued in the industry, like going to finance, finance as well as like AI, ML, everything. So it is like you can take, you see, it's not like all PhDs. So PhD, also the idea of PhD has changed. Earlier people did it, okay, for the love of it and doing it, but now it's also like acquiring a higher educational qualification. So you move on to something better. And the fact that some people have taken up jobs in, say, non-astronomy fields doesn't mean that their passion has died out.
True.
It's just, but it is okay. It's good. Actually, astronomers are probably more highly employable than a laboratory physicist.
Yes, but
If you ask
when
me.
it comes to answering questions, when people say, when they're coming into this field, should I, what am I going to get later?
Yeah, but you can tell them that you will be learning all these skill
But
sets.
you are saying it because, ma'am, you have experienced that.
No, I'm saying,
I
so
can
that is a
give
good
them
thing.
that
Actually,
experience.
is
They
more
don't believe,
scalable than any
True.
of the other. But academia and basic sciences anyway is suffering.
Yeah.
The enrollment in undergraduate level is going down.
But
That
we
is
try,
what is going
but
to hit
we
us also.
People won't understand this directly. I mean,
Yeah.
especially when students are choosing a career, they won't choose that as a career. They're already
Yeah, but
saying, no,
young
we'll go for
minds,
this
often
branch.
young minds are actually, they are more fascinated by something.
Yes.
So if you can feed the parent that, okay, there will be a nice pay package, they can continue doing this, and but then the skill sets they will develop will eventually could, if they're good at it. But everybody has to be good in what they're doing. You cannot guarantee a job. It's true with engineering, as she mentioned. So many engineers are being we are getting so many graduate engineers. Do we have job opportunities?
No, but ma'am, here they also talk about the number of years spent to
Yeah,
become
so
good
that is
astronomer.
that
Up to
is one
12,
thing. But
BSc, MSc, PhD, and then a postdoc. It's
yeah,
a
so
huge-
these are all
nobody
things,
wants to invest so much of years for
understand.
their career. That is also another problem.
Yes.
Thank you.
I think with this we can thank Professor Dabhade. But we still have some minutes remaining for the session. So I think we can reinitiate some of the discussions which were left. Probably there were more questions to be asked to Chandray or Sivrani or also to Professor Dabhade. You can just throw the dice open and just get going. So maybe Sivrani, you had the least time because we had to cut short because of the other talks. So if you have questions regarding her instrumentation expertise, I would be very interested to hear on that, or there are other questions, then please ask questions. No, there's 10 minutes. We need.
It's about the neutron stars. You said, the products would be different if the merger happens between two neutron stars which have different masses. So how different? No, I'm saying, what would be the masses of the before merger of the neutron stars? One is 1.2 and another is. It has to be substantially different for the original material to be sort of different so that it gives us a. So that's what I wanted to.
Yeah, the idea is also like not just the ratio, the overall production also they have to match. So they were able to match the.
Right.
So these two aspects.
Okay, so no, this is very interesting. Maybe I'll catch you later. Thank you.
Ma'am, I have a question for you. Can we use our process to distinguish stars from external galactic that are getting accreted into our galaxy?
Yeah, so that is a very good point, because as I was showing about this metallicity decline, like our process elements can be only produced at with neutron star mergers. It will take a long time. So by the time the galaxy would have enriched to a certain metallicity. But in the case of other galaxies, not like Milky Way, they would have had a different star formation rate. They wouldn't have enriched so quickly like Milky Way. Like, for example, dwarf galaxies, they take a long time to increase the metallicity. So by the time there would be enough time for a neutron star merger event to happen. So you would expect, as you said, dwarf galaxies to produce more neutron-rich elements. But so far we have known about 2 satellite galaxies of Milky Way, which has very high enriched. So we think if this time scale is the problem, most of the neutron-rich our process-rich stars in our galaxy would have been accreted from some other galaxies. So that is the current proposal, but kinematics doesn't agree with that. It looks like it is formed within our halo. Yeah.
One more question, ma'am. How are these metal poor stars being distributed along the galactic height when we come?
Yeah. So normally, as the way the galaxy forms, you would see the first stars would have formed at the center of the galaxy. But then the enrichment happens very quickly in the center. So, but in terms of detection, if you want to see in the outer halos, you would see the stars, more metal poor stars in the halo region. Yeah, but in terms of age-wise, if you want to look at the very first stars, then Centrus is the best, but it's difficult to detect them.
Thank you, ma'am.
Hello, ma'am. I would like to ask you regarding the TMT instrument that you said, the azimuthal position that introduces the distortion. So how is that error fixed?
Yeah, so basically when you track an ultra-azimuth telescope, you have to move both in altitude and azimuth, and also the field rotates. So what happens is, the instrument is normally big, like there is also a scaling, like as you go with the larger telescope, you would need, the instrument size becomes bigger, because for a seeing limited instrument, the physical size you want to let all the light of the seeing disk to go through the spectrograph slit, the physical size of the slit becomes bigger. So hence the instrument becomes very big. So in a small telescopes, you can have an optical derotator, which will rotate it. But in the case of big instruments, you have to physically rotate the instruments. So if it is, so there will be a time-dependent flexure, so which has to be compensated by like actually in Keck DMOS, what they have is they also have some calibration sources, like for which you know the positions, and they actually detect them with a much faster rate. Like for example, your exposure time is, let's say, 1 hour you are integrating, but you will have a like in the sides of the detector, you would have some calibration sources which are read out at a faster rate.
And then when the spots move, you correct the detector motions and also rotate them to correct it in a much fast. Yeah, it's a closed loop corrections they do. Yeah. So, but in the case of TMT, that was not possible because just the shifting and the rotation is not sufficient. There is a field dependence, so you have different position of the detector has to be moved at different distances because of the distortion in the optical design itself. So that.
Thank you.
Hello. Yes, sorry, ma'am.
Yeah.
That was a very lovely talk. I'm
Thank you.
Fatima, undergrad student. So I have a very layman question. I hope that you might just answer it. So I just wanted to have a clear understanding on this R1 R2 process of nucleosynthesis, particularly in this supernova and other stuff.
Yeah, okay. That's a very good question. It's not a naive question. Like, so people always thought supernovae are the sites to produce these R process elements because it has the energy to produce. But currently, the models we can't produce in a normal core collapse supernovae. So the reason is there are two things which are needed for rapid neutron capture. So you need the energy as well as the neutron densities. So what happens in the case of more massive supernovae? So at the time of because it will at the time the explosion stalls, so you would end up with a alpha-rich ejecta. So there is not much neutron. So it's, I think you have an expert there. Gina is there. So she works on actually modeling them. So you can ask her. She actually, she's an expert in that area. So it's so currently a very small range of supernovae. People think it is possible to make these R process, but neutron stars, since they have neutrons, so that is so when they are degenerate, but in the case of when they collide, like come together, so that the degeneracy is lifted in the outer regions, and then the neutron will be converted into proton, and then they keep building all the way. So that is the one easy, very physically easier sites to make. Yeah.
This is a follow-up on that. So now that we have established that neutron stars are laboratories for our processes and higher element formation, can we somehow, from the abundance of these higher elements in the universe, back model and get a mass function of the neutron stars?
Yeah,
Or
that is the
merge
whole idea of studying the metal poor stars. We want to trace back the initial mass function of the first stars, which we don't see now, but they are died yeah. So currently still the neutron star merger is one of it's a physically easy, and also we have seen a direct evidence, but still there are open problems that neutron star mergers cannot actually match with the abundances. So we are still looking for sites that
Right.
are.
So there could be something else other than the neutron star.
No, neutron star merger. Yes.
Thank you.
More than a question, it was a comment, actually triggered by Shivrani's talk. I hope that one of the outcomes of this meeting will be that people will take on the spirit of this meeting. To me, one of them is that when you give scientific talks, you also talk about the processes within science, the way Shivrani did, because the processes actually have a huge impact on the scientific outcome. But our training, certainly for me, I mean, I'm one of the oldest in this room, our training is that just talk about your science. Don't talk about what your experience was, what your failings were, what went wrong. Only talk about what succeeded, your published papers, etc. And I think that is the wrong approach. And I think it doesn't serve science well. So, and it becomes like only in these sort of meetings, which are sort of women in physics or gender, etc., is where the speakers are encouraged to talk about both what they did and what the processes were. So I hope that that can be mainstreamed, so it doesn't only happen in a waves meeting or in a gender and physics meeting, but it happens in every meeting, that every scientist is encouraged to give that kind of mixed kind of talk, because it actually affects the science. And so it's ridiculous to pretend that it doesn't. So I just wanted to make that comment, and it's really nice. I think Shivrani set a very good example of that.
Thank you, Preeti.
Actually, there was this other thing planned at 1:10 that so there are meetings happening concomitantly at the same time. So the idea was to go to the other hall and usually our director Rajesh Gopakumar, he talks about programs and so on that happen in the institute, and that's usually a nice thing to listen to. But given that we don't really have too much of time, I would leave it to the interest of people who want to go and listen to that. So the other thing is that today we have the maximum attendance, I think. Some of us will probably not be there tomorrow. Though we don't really have like the official photographer at the moment, we will still take mobile phone photographs. Let's just do that right away, and then we can just proceed to lunch. Thank you.